Good morning, children. This is Rajaratnam Pratipati. First of all, congratulations to all of you because you have selected New Vision institutions. That is a very good decision. Congrats. These classes are meant for the students who are new to foundation. So far, we have discussed nature of matter and the language of chemistry. This is a third topic, types of chemical reactions. In our daily life, in our surroundings, we will observe different changes around us. Different changes, growing of plant, rusting of iron, setting of curd, different changes. Among them, some are physical changes and some are chemical changes. The changes which are reversible and some changes are chemical, those are irreversible. In physical changes, there is no new substances are formed. But in chemical reactions or chemical changes, we observe new substances. So some are physical changes and some are chemical changes. For example, evaporation of water. In summer season, we observe here evaporation of water. Here water liquid converted to water vapors. In this, there is no change in chemical composition, just physical state changes. These type of changes are called physical changes. In some changes, for example, whatever the iron nail, iron piece, exposed to atmosphere, iron solid, here Fe converted to Fe3O4 when it is exposed to moisture. So here iron Fe, this is Fe3O4. So there is a change in chemical composition. These changes are called chemical changes. All the changes are divided into physical changes, chemical changes. Whatever the chemical change observed, whatever the chemical change happened, that is considered as a chemical reaction. Whatever the chemical change happened, then that is considered as a chemical reaction. In chemical reaction, here the substances which are undergo the change, those are called reactants. And the new substances are formed, those are called products. This is a chemical reaction. The substances which are involved in the chemical reaction are called reactants, and the new substances are formed, those are products. So whatever the chemical change taken place, that is considered as a chemical reaction. And the chemical reactions are expressed in terms of chemical equation. Chemical equation. Here, this is a chemical equation. Chemical equation means it is a shorthand representation, shortcut representation of the chemical reaction. By using what? These are symbols and these are the formulae. That means chemical equation is a shortcut representation of chemical reaction by using symbols and formulae of the substances, whether reactants or products. That is called chemical equation. So here the changes, among the changes, some are physical changes and some are chemical changes. Okay, here chemical change happened means that is nothing but what? Chemical reaction. So here types of chemical reactions. Here first one is chemical combination reactions. Here, the meaning of chemical combination. Combination and meaning itself. Combination. Combination means A plus B gives rise to AB type. These type of reactions, A plus B gives rise to AB. A is one substance, B is another substance. Both substances are combined together to form a new substance. In chemical combination reactions, here more than one reactant, and here product should be single one. These are called chemical combination reactions. In combination reactions, that may be element plus element combined together to form compound. Element plus compound gives rise to compound. Compound plus compound gives rise to compound. Special name of these reactions, element plus element gives rise to compound reaction. Combination reactions are called synthesis reactions. Synthesis. For example, H2 plus O2 gives rise to H2O. Look at this, hydrogen is element, oxygen is another element, element plus element. Here H2 is compound. Element plus element gives rise to compound. Here SO2 plus O2 gives rise to SO3. SO2 is a compound, O2 is element, SO3 is compound. So here compound plus element gives rise to compound. Here NH3 plus HCl gives rise to NH4Cl. Ammonia, hydrochloric acid, ammonium chloride. Ammonia is one compound, HCl is another compound, and NH4Cl is new compound. So compound plus compound gives rise to compound. Here we have three different types of combination reactions. Element plus element, element plus compound, compound plus compound. Element plus element combination reactions are called synthesis reactions. Here, this is nothing but synthesis of water. Here, combination reactions, different types of combinations are discussed. Look at this. Sodium plus oxygen. Sodium is element, oxygen is element. Here, this is nothing but metal. Here, metal oxide. Metal with oxygen. Here, non-metal with oxygen. Sodium is metal, carbon is non-metal. Metal with oxygen, metal oxide. Non-metal with oxygen, non-metal oxide. Metal with chlorine, metal chloride. Here, non-metal with chlorine, non-metal chloride. Iron is metal, chlorine. Hydrogen is non-metal, chlorine. Here, metal with sulfur, metal sulfide. These two are oxides, and these two are chlorides. Metal with oxygen, metal oxide. Non-metal with oxygen, non-metal oxide. Metal with chlorine, metal chloride. Non-metal with chlorine, non-metal chloride. Here, metal with sulfur, metal sulfide. Here, non-metal with sulfide, non-metal sulfide. These two are called sulfides. Here, metal with nitrogen, metal with nitrogen. metal nitride. These are all element plus element type combination reactions. These are called nitrides. Oxide formation, chloride formation, sulfide formation, and nitride formation. If you observe higher oxide formation means lower oxides are converted to higher oxide. For example, carbon monoxide, this is lower oxide. Carbon monoxide with oxygen produce carbon dioxide. This is lower oxide, this is higher oxide. These are comes under which category? Carbon monoxide is compound, oxygen is element, CO2 carbon dioxide is compound. So compound plus element gives rise to compound category. Here SO2 plus O2 gives rise to SO3. Here NO plus O2 gives rise to NO2. These are all comes under which category? Compound plus element gives rise to compound category. Is it clear? Next, look at this. Calcium oxide plus water gives rise to. Here calcium oxide, metal oxide, this is water. Here this is a CaOH taken twice, calcium hydroxide. Calcium oxide plus water gives rise to calcium hydroxide. This is a compound, this is a compound, this is also compound. So this comes under compound plus compound gives rise to compound category. That too, this is a metal oxide. Metal oxide. Here this is a metal hydroxide. This is nothing but base. Base means the substance which turn red litmus to blue. Look at another one. Here carbon dioxide plus water gives rise to carbonic acid. Carbon dioxide. This is nothing but non-metal oxide. Non-metal oxide. Here H2CO3 is what? Acid, carbonic acid. So metal oxides dissolved in water, they produce bases. Non-metal oxides dissolved in water, they produce acid. Here base turns red litmus to blue. Here acid, blue litmus to red. Is it clear? These are called combination reactions. Once again, combination means A plus B gives rise to AB type. Element plus element, element plus compound, compound plus compound category. Here bases. Here CaO dissolved in water, it produces CaOH taken twice. Here this is basic in nature. Okay, but in some cases copper oxide or cupric oxide. Here this cupric oxide does not dissolve in water. Then this is considered as alkali. It is considered as base. So simply soluble bases are called alkali. Insoluble bases are not considered as alkali. These are only bases. Cupric oxide only base, it is not alkali because it is insoluble in water. Calcium oxide base as well as alkali. The meaning is the base which is dissolved in water, soluble base. Dissolved in water means soluble base. So soluble bases are called alkali. Similarly, here H2CO3. H2CO3. This is what? Acid. If you remove water, you get what? Carbon dioxide. This carbon dioxide is considered as acid anhydride. Acid anhydride. The meaning is the acid. This is acid. If you remove water, anhydride means without water. Elimination of water. From acid, if you remove water, you get acid anhydride. For example, H2SO4 is there. This is sulfuric acid. If you remove water, tell me, what is the compound obtained? H2O, removal of water, you get SO3, sulfur trioxide. So SO3 is acid anhydride of sulfuric acid. CO2 is acid anhydride of carbonic acid. So from acid, by the removal of water, you get acid anhydrides. Is it clear, children? This is about chemical combination reactions. The second type of chemical reactions is decomposition reactions. Decomposition. This is quite opposite to combination reactions. What is combination reaction? A plus B gives rise to AB. Here, combination, combining, joining of two substances. That may be element plus element, element plus compound, compound plus compound. Here, decomposition is quite opposite, reverse of the reaction. Means AB gives rise to A plus B. Is here, this is one substance that is divided into, decomposed into, dissociated into. Decomposition. Decomposition means separation. Here, this is a single substance that is separated into more than one substance. In combination reaction, very important. In combination reaction, here more than one reactant, but the products are single product. But in this, reactants are single reactant, but the products are more than one product. Okay, these type of reactions are called decomposition reactions. Similarly, here the compound decomposed into element plus element, or compound decomposed into element plus compound, compound gives rise to, or compound decomposed into compound plus compound. Here, these type of reactions are called analysis reactions. Element plus element gives rise to compound or synthesis. Here, compound gives rise to element plus element are called analysis reaction, special name of the reaction. And one more important thing, if you observe this, AB gives rise to A plus B, means whatever the compound decomposed, dissociated, means here the energy is required. In the case of AB gives rise to A plus B gives rise to AB now. These are called combination reaction, joining. Joining reactions, energy released. Energy released. But here for decomposition, to break the bond, to break the compound into element plus element or element plus compound or compound plus compound, here energy is needed. Energy is required. That's why these reactions are called endothermic reactions. Energy is required. That energy may be heat energy or electricity or light. That energy may be heat. Means, for example, here whatever the compound taken in the boiling test tube, and when we heat this by using Bunsen burner, energy given in the form of heat to decompose the compound. energy is required in the form of heat, then those reactions are called thermal decomposition reactions. Thermal decomposition. Here thermal means heat energy. Here electricity. Electricity means by taking electricity, by using electricity, if you decompose the compound, then those reactions are called electrolytic decomposition. Electrolytic decomposition reactions. In the presence of light, decomposition taken place. Those are called photochemical decomposition reactions. Photochemical decomposition reactions. So here to decompose the compound, here energy required in the form of heat, thermal decomposition reaction. Energy required in the form of electricity, electrolytic decomposition. Energy required in the form of light, those are called photochemical decomposition reactions. First one is thermal decomposition reaction. Thermal decomposition, look at this here, calcium carbonate, lime, marble, okay, chalk, whatever the substance, formula is calcium carbonate, CaCO3. Here thermal decomposition, that symbol represented by delta. This is the symbol used for the thermal decomposition, heating symbol. When we heat this, it decomposes into CaO plus CO2. This is the compound, here compound, here compound. Compound gives rise to compound plus compound reaction. That too, here this delta symbol represents what? Heat. So this is thermal decomposition reaction. Similarly, electrolytic decomposition, H2O. Here we use electricity, H2 plus O2. H2O compound gives rise to hydrogen plus oxygen, constituent elements, by using electricity. This process is called electrolysis reaction. And here third one is photochemical decomposition. AgBr gives rise to Ag plus Br2. Here the symbol is H nu. This is called light. In the presence of light, a compound decomposed into element plus element. These reactions are called photochemical decomposition reactions. So simply decomposition reactions are what? How many types? Thermal decomposition, electrolytic decomposition, and photochemical decomposition reactions.